Okay, hello everyone. Welcome to our 7th lecture in our course Competition Policy and Strategy, which is the English version of my German lecture that I gave in 2020 with the title Wettbewerbspolitik und Strategie. Today we're going to talk about merger control. So everything that is associated to two parties or more becoming one. We will learn what that exactly means, the economic implications, and how to analyze these and to evaluate these mergers. The lecture is going to be split into two parts. The first part will be basically the foundation, and we're going to talk about horizontal mergers, and in the second part we're going to talk about vertical mergers and conglomerate mergers. Before we start, please like the video and subscribe to our channel. That would help us a lot in expanding the reach of our channel and to bring economics more towards the public. Okay, so let's begin. Mergers and merger control, the basics. So in the European Union, there is a directive that basically regulates how we deal with mergers and what mergers actually are, how they are treated, and so on. And that's the Council Regulation number 139/2004. And there we have a definition of a merger, which is also called concentration, in Article 3. And it is defined as lasting control of a merger between two or more previously independent parts of an undertaking or undertakings. And the acquisition can be by persons who already controls one undertaking, by contract assets, or direct or indirect. And the control over the merged entity has to be given, so there has to be a decisive influence. So if you just buy a share of a firm, that's not considered a merger. Okay, so what is important here is basically, the ideas of mergers should be pretty clear. Here is important to note that we have to have a lasting effect, and that it's not about minority shareholdings or anything like that. So it's about decisive influence and control over another firm or two firms becoming one, basically. And that's how we think about it in economic terms, usually. Then in Article 2, we have the evaluation of the merger. And from an economic perspective or economic policy perspective, we want to maintain and develop effective competition and potential competition in the common market of the European Union. We want to prevent the creation or the strengthening of a dominant position of the involved firms. Pretty clear. If we take out a competitor, that means that the firms are in the market basically become more dominant, and we want to avoid that, which doesn't mean that a merger always creates these negative effects. That's something we were going to be analyzing. We want to maintain alternatives to the buyers and other suppliers. We want to prevent foreclosure and entry deterrence, very crucial aspect. We will talk about foreclosure in more detail. Basically, we have input foreclosure and customer foreclosure, which basically means that if you talk about input foreclosure, then you have upstream firms and downstream firms. And if you want to talk about input foreclosure, it should be a situation where an upstream firm merges with a downstream firm. That can lead to a situation that another firm is no longer supplied, so it's foreclosed from inputs. Or if we talk about customer foreclosure, that means that a merger between an upstream and a downstream firm leads to a situation where another upstream firm is basically cut off from the market. That's what we're going to talk about in the next lecture, not in this one. Entry deterrence is also related to that. We want to maintain technical and economic progress, a goal that we always have, and we want to prevent coordinated effects. We're going to talk about that today as well. Okay, so then we talk about what actually is a merger that is of community dimension, which basically means that it is investigated by or is potentially investigated by the European Commission, right? And that's defined in Article 1. And you just have to go through the definition. It's a combined aggregate worldwide turnover of all the undertakings concerned is more than 500 million euros. The aggregate community-wide turnover of each of at least two of the undertakings concerned is more than 250 million euros, unless each of the undertakings concerned achieves more than 2/3 of its aggregate community-wide turnover within one and the same member states. And if these criteria do not hold, there is still the possibility that we have a community dimension if the combined aggregate worldwide turnover of all the undertakings concerned is more than 2,500 million euros. In each of at least 3 member states, the combined aggregate turnover of all the undertakings concerned is more than 100 million euros. In each of at least 3 member states included for the purpose of point B, which is the former point, the aggregate turnover of each of at least 2 of the undertakings concerned is more than 25 million, and the aggregate community-wide turnover of each of at least of the 2 undertakings concerned is more than 100 million euros, and unless each of the undertakings concerned achieves more than 2/3 of its aggregate community-wide turnover within one and the same member states. Okay, so you shouldn't learn this by heart, I guess. It doesn't make a lot of sense. So if you want to check whether a given merger is of community dimension, you just go to this regulation and see whether the conditions are met or not. So that's basically from an economic perspective, it basically means that the firms are large enough to have a potential effect on the European of the common market of the European Union, and that, you know, if there's a restaurant in a local, if a local restaurant is to merge with another local restaurant, it's very unlikely that this is concerned, that this has community dimension. Whereas if two, multinational firms with a few billions turnover merge, and all of them are, or basically most of their business is in the European Union, then it's very likely that this is of community dimension, right? So this is basically just why we have that. Okay, so what basically does this community dimension mean in terms of what the community or what the Commission does? So what happens is that the merging parties have to notify the merger or the concentration to the European Commission, and then it's basically going to be investigated by the Commission. And you can see the data of the merger statistics in this through this link. I've taken this data as of October 2022, and at that point we had 8,083 mergers, and that's a lot, basically. So it's the entire time frame that is given there. And we have phase 1 decisions, so decisions that are taken after 25 workdays after notification, so relatively quickly. And we see that 170 cases, which is almost 90%, were decided in this phase 1. So most of the things happen immediately. And what happens, or potential outcomes, would be clearance, which basically means that the firms are allowed to merge, so no problems here. It could be referred to a member state, which basically means that, okay, so it's basically not of community dimension, or we proceed to phase 2, right? And if we proceed to phase 2, then we potentially have problems with the merger. So it basically, what we learn from here is that most mergers are basically cleared. So they are considered compatible with the common market, right? And that is corroborated if we look at phase 2. In the phase 2, we have 90 workdays, so it's a more sophisticated investigation that takes place, and we see that 282 cases are decided in phase 2, which is 3.5%. Keep in mind that some cases were basically drawn from the investigation during that point by the firms themselves. And out of these 282 cases, we have 140 cases with commitments. I will explain what that means in a minute, which is around 1.7%. 30 were prohibited, and 5 were basically prohibited with restoration. So very few mergers, 35 basically, are out of 8,000, more than 8,000 mergers, were basically not cleared, right? So regarding the outcome of phase 2, we have again the clearance as a potential outcome. We see that most cases are actually basically deemed compatible, and they could also be compatible with commitments. And these commitments, they can involve structural or behavioral remedies, which basically means that the firms have to do certain things in order to alleviate the competition, the commission's concern regarding the negative or potential negative effects on effective competition in the market. It could, for instance, mean that in order to prevent foreclosure, we design some sort of framework contract that everybody who wants to enter the industry or wants to get a certain input or wants to sell its goods over via a certain downstream supplier has access to this, right? And that is usually considered a commitment. And that basically means that the merger is okay. However, we have to give certain commitments in order to really clear the merger. And then we can also have prohibition. And this prohibition can also mean dissolution or restoration of the pre-merger situation, which basically means that if the merger already took place and the commission decides that the merger was basically not okay, then we have to restore the situation pre-merger, which basically means that we have to re-merge the parties, right? Okay, and if the firms are not okay with the decision, they can go to the next instance, which would be the European Court of Justice. Okay, so how is the situation in Germany? In Germany, we have paragraph 35 GWB, Gesetz gegen Wettbewerbsbeschränkung, and these rules apply if, again, we have certain conditions here. The worldwide turnover of merging parties in total over 500 million euros, so they have to be large. And the revenue of at least one of the merging parties in Germany is over 25 million euros, and that of another one of the merging parties is over 5 million euros. So the revenues have to exceed a certain threshold, otherwise the merger is basically not important, right? And there's also several other conditions that play a role here, and it's, for instance, the price of the acquired entity and so on and so forth, right? So I'm not going to write this down, just look at the paragraph if you're interested, or if you want to know if a certain merger has to be notified. Okay, so from an economic perspective, we ask ourselves a few questions, and these questions, of course, the first one is, when or why is a merger beneficial to firms? So why do firms merge, right? So that's the first thing we are interested in, one crucial question. Then, how does the merger affect consumers, right? So we have talked about whether the merger is beneficial to competition or detrimental to competition. And that, of course, involves the consumer's perspective. And it's also important to examine how the merger affects other competitors in the market. Again, we want to maintain an effective competition in the market. And the economic analysis, requires a market definition first. And that's pretty crucial. I've told you, during the last lectures, oftentimes that in order to investigate the merger, we have to have a good understanding what the relevant markets are, right? So all the things that we're going to talk about now, they rely on us having defined the relevant market before. So, recall the SNP test, UPP test, and so on and so forth, right? So what we talk about now requires that we have done that before. And another thing is that whether the merger generates unilateral or coordinated effects. It's important to keep that in mind, since this is a term, or these are terms that come up relatively often. And unilateral effects are basically coming from a situation where one firm is put in a more advanced position after the merger, and this gives the firm an incentive to raise prices irrespective of what the other firms do. That's why the term unilateral applies. And then there's also the other term, which is called coordinated effects, and that is the ability of the firms to coordinate, or the increased or enhanced ability to coordinate post-merger, right? And especially this is an issue when we talk about collusion, and we will talk about collusion in chapter H, and that's really a big concern here. Okay, so we will start our investigation whether or when a firm when a merger actually takes place with a very simple model. So we use a Cournot oligopoly with n-symmetric firms. We have a linear demand function, A minus P. We have constant marginal cost C. And with this setup, we've learned that in chapter B already. So just check out the lecture if you want to know how we derived that. But here you see the respective expressions for each firm's or firm I's individual equilibrium output, the equilibrium price, the equilibrium individual firm's profits, and consumer surplus, each as a function of n. And what we do now in order to investigate the merger is to assume that out of these n firms, m firms merge. So that means that m firms become one firm. So we have post-merger a new number of firms, which is n prime, and n prime is n minus m plus 1. So what you do basically is to start with the original number of firms, you take out the merged entities, and you realize that the merged entities are not gone, but they are now one entity. So you add plus 1 here. Just as an example, assume that out of 9 firms, 3 firms merge. That means you have a new number of firms of 9 minus 3 plus 1, right? And that would be the result of our post-merger number of firms. Okay, so how do our expressions for output, prices, profits, and consumer surplus look like post-merger? You have the expressions here. So what you basically do is to just substitute n by n prime in the former equations or expressions, and that's what you get, right? And based on these results, which are now a function of n, so the pre-merger number of firms, and m, the number of merging parties. Based on these expressions and the former expressions, we can now ask ourselves, when does a merger pays off, and how many firms do we need to merge in order for that merger to pay off? And what we see is that, or the crucial condition here, is that that the merger pays off if and only if the post-merger profits of a single firm exceed the pre-merger profits of M firms. Why is that? Well, it's basically you have to ensure that the firms have an incentive to merge. That means that they have to be better off with the merger than without the merger, i.e. each firm's pre-merger profit has to be lower than that firm's post-merger profits. And this is exactly what we have written down here in this equation. What you could also do, you could simply divide this inequality by M, and you would see that 1 over M times total post-merger profits have to exceed one firm's pre-merger profits, right? So that's exactly equivalent. So the premise is that if you earn 100 euros before, or 1 million euros, and before the merger, then you merge, and the total profits of all the merged parties would be 1 billion euros, and we would have like 4 merged entities. That would mean that the 4 merged entities prior to the merger would have earned 400 million, whereas 1 merged entity after the merger would earn 1 billion. So this pays off, right? And that's what we have here in this condition. Now, in order to get a better understanding of what this actually means, we substitute for M with X times N. And X is basically just a share, so a real number between 0 and 1. And it basically captures the idea that we want to know what the market share, what share of firms in the market would have to merge in order for the merger to pay off, right? And what you do is to substitute or to plug in this X times N for M in this inequality that we see here. So this one, so you just use this here and here, and solve for this inequality, or you set it equal and rearrange it with respect to X, and then you get this expression here. And this is basically the minimum share of firms in the market that have to merge for a merger to pay off. Why is that the minimum share? Well, it's pretty simple. That if you derive that X prime N, what you do is to set an equal sign here and rearrange, and you know that if all firms in the market merge, then we have a merger to monopoly, and that always pays off, right? So it's always beneficial to get to 100, whereas if only one firm merges, well, it could not, or if only 2 firms merge, it probably doesn't really pay off, so it depends. So what we want to have is that X, so the actual number of, or the actual share of firms merging in the market has to exceed X prime here in order for the merger to pay off. That's our condition. And now the question is, how does it look like? And if you plot the function here for an example with some numbers, what you basically see is that for n in the range of 2 to 100, you always see that the lowest tip of this function is basically at 0.8, which basically means that at least 80% of the firms in the market have to merge in order for the merger to pay off. And from a reality perspective, that seems quite counterintuitive, as you might think, well, okay, if firms merge in the market, they get an advantage. Reality is that's basically not the case, right? And the question is, why is that actually? And that's called the merger paradox, or merger paradoxon. And it basically means that exactly what I've told you, at least 80% of the firms in the market have to merge in order for a merger to pay off. And the point here is that if a given number of firms merge, then this, of course, reduces the intensity of competition in the market. And the firms that are not involved in the merger, they benefit from these effects. So if you are a firm that is not involved in the merger, and we start off this from this Cournot perspective, and that's no other effects are involved, then it's good for you if the other firms merge, because basically it decreases the number of firms in the market, which increases prices, and that's good for you, right? And from the merging parties perspective, it is the case that what you have to compare is your pre-merger profits to the post-merger profits. And if you don't have enough firms merging, then this intensity of competition effect that increases each firm's profits does not overcome the sheer amount of pre-merger profits that we have here. So if there's two little firms merging, then 2 times, for instance, 2 times the pre-merger profit exceeds the post-merger profit. Then it wouldn't pay off to merge. Whereas if you move towards a merger to monopoly, the intensity of competition effect becomes relatively strong, and this overcompensates this basically fraction part of your profits, right? And now, from a consumer's perspective, what we have here is basically that the merger reduces consumer surplus, which is pretty clear and straightforward, and it's easy to explain. What the merger does in our example is to just reduce the number of firms in the market. And in our Cournot world, this basically always means that we have an increase in prices and a decrease in output. And that is, of course, detrimental to consumers. So we would always block these mergers, because it's not good for consumer surplus and it isn't good for welfare. Okay, but does this mean that we should block all the mergers in the world? Well, the reality is, of course, not. We can think about many situations where mergers could be beneficial, and a first extension that we should take into account is cost efficiencies, right? And what this basically means that if the firms merge, they can use synergies to decrease their costs. And we can think about 2 cost components, the fixed costs and the variable costs, that can be reduced here. And if we just use our condition for the merger to pay off from before and include fixed costs, capital F here, then we see that after the merger, you have 1 times the fixed cost, whereas prior to the merger, or pre-merger, you have m times the fixed costs. So what you basically do is to reduce the amount of fixed, or the intent, or the scope of fixed cost application, and that increases the incentive to merge. And we can look at the minimum share of firms involved in order for the merger to pay off on slide 12, which is the next slide. And we will see that it alleviates the problem. However, and that's the problem from a competition policy perspective, for the consumers, fixed cost savings do not play a role at all. Why is that? Well, if you look at pricing in Cournot, it doesn't matter how high the fixed costs are, because they cancel out if you differentiate the profit function, which basically means that they have no effect on the reaction functions, thus no effect on individual equilibrium outputs, and no effect on prices, unless we have some certain calibrations where it's you have to cover some fixed costs in order to be productive, and then it probably gets an issue, but that doesn't happen on our standard models. Okay, so our second extension, what happens if the merger reduces variable costs? And the idea behind is that we have, in the pre-merger situation, efficient and inefficient firms in the market. That means that we don't have symmetric firms, but firms with different variable costs or marginal costs. And the idea is that if there is a merger between an efficient and an inefficient firm, then we would anticipate that the efficient firm adopts the inefficient firm adopts the efficient production technology post-merger, thereby reducing their variable costs to the efficient ones standard. And that increase in productive efficiency potentially might lead to lower prices, or higher quality, or innovation, and we can also probably think about learning effects that play a role here that could benefit the consumers. The thing is, in reality, the merging parties have to prove this efficiency, and it is sometimes pretty tough. Okay, so I promised you to look at the XF, which is the function with fixed costs, and we see that the minimum share of firms being involved in the merger is lower if we have fixed cost efficiencies. In the given example here, so we have fixed cost of 90 in the given calibration that you see down there. So the orange function, the minimum share of firms being involved in the merger, is below the blue function, which basically means that you have to have less firms in order for the merger to pay off. So more realistic, but probably still not very satisfactory, as you see that if we're in a low number of firm environment, it's still pretty close to 80%, so probably not the best explanation. Of course, the functions do change when we vary the amount of fixed cost, but that's that's just a calibration exercise. Anyway, what else can we think about? Well, in reality, it could be that if you merge, you become quicker than the others. So you probably become a market leader. And that means, if we translate that into our theory, that the merged entity becomes the so-called Stachelberg leader. And that is based on the idea of sequential quantity competition. So I've told you in our second lecture that aside from Coulomb models, we have, in addition to Coulomb models, we have the Stachelberg model, which is also a quantity competition, but it's sequential and not simultaneous. And the idea here is that in the pre-merger situation we have, well, Stachelberg doesn't always have to be about mergers, it could be about anything, but we can apply it to mergers pretty easily or in a pretty straightforward way. And the idea is that in the pre-merger situation we have the symmetric kernel that we have already analyzed, and in the post-merger situation the merged entity becomes the Stachelberg leader, which we indicate by small l, and the remaining n-m firms become the Stachelberg followers, indicated by a small f. And what basically happens, or from a theory perspective, how we can solve what happens, we have to apply backwards induction. And the idea is that the Stachelberg follower moves second and the Stachelberg leader moves first. And backwards induction means that we look at the followers first and then assume that the leader anticipates what the followers will do on a subsequent stage, right? So you can think about this in a way that the merged entity has a certain advantage in the market, so it produces first, and then the others observe what the leader does, and they decide on how much to produce, right? And this idea translates into this Stachelberg leader example that we have. So how can we understand what happens? So first, we again have to apply backwards induction. So we look at the follower, at one specific follower first. And we just abuse notation here slightly, and we assume that this follower that we look at has index f. And what this follower does is that it chooses its output in order to maximize its profits, and its profits are a function of its own output, the output of the leader and the output of the other followers, q minus f. And if we write down this function, then we see that these arguments basically enter in the price function or the inverse demand, and we see that the inverse demand is a function of the followers output, the leader's output, and all the other followers outputs, and it's times the followers output that we are examining minus the cost of this follower, right? And if we differentiate this function with respect to f, what we have to take into account is that the followers, except for the followers of the follower that we are examining, are all symmetric. So, sorry, all followers are symmetric. That means that the output of all the followers, except for the one that we are examining, is is the same, right? So Q minus F now is N minus M minus 1 times QF. Why is that? Well, N minus M plus 1 is the number of firms after or post-merger. Out of these N minus M plus 1 firms, we have one leader and one follower that we are examining, right? And these two firms we have to take out from the set, basically. So if we have 9 firms and we have a merger of 2 of them, then we have 8 firms after the merger, which is pretty clear. And out of these 8 firms, what we do here as Q minus F is we take out the leader that we are examining, and we take out one of the followers that, we take out the leader's output and the output of the follower that we are examining. So that means that from the follower that we are examining, from his perspective or from her perspective, what the other followers do is 7 times what I do, right? Because the leader behaves differently and there are 7 other followers in the market, right? And from this we can get the follower's reaction function. And now this is just a function of QL, because what we basically do is to rearrange this FOC with respect to QF. We will see how that might look like in a given environment on the next slide. And now this is the first stage of the game. Sorry, the second stage, but the first, solution step. And if we want to solve for the equilibrium, we just have to assume that the leader anticipates the follower's reaction function. So from the leader's perspective, we maximize over QL, so the leader produces output in order to maximize its own profits, and the output of the leader enters the inverse demand function directly and indirectly via the follower's reaction functions. So what the leader does is basically anticipating that if it produces a given amount of output, then a follower reacts in a certain way, and in anticipating this, the leader can control how much output there is in the market, basically, and that's the advantage that the leader has. Now, in order to see that, we can use a given simple linear demand function and constant marginal costs. And if we do that, and we plug this into our follower's profit and differentiate this function with respect to QF and rearrange with respect to QF, we get this this function here. We see that this is QF as a function of QL and Q minus F, so this is not already a reaction function. We have to factor out here that the other followers act symmetrically to the follower that we are examining. So what we do is to substitute for Q minus F N minus M minus 1 times QF here. As I explained to you before, all other followers behave symmetric to the follower that we're examining. So we plug this in to here and rearrange with respect to QF in order to get to the reaction function of a given follower, which is this one here. And this reaction function, of course, only depends as our endogenous variable on the leader's output. Why? Because each follower anticipates that the other followers behave the same. So each follower observes the leader's output and knows how all the others will produce. So it only depends on the leader's output what a given follower will do in equilibrium. Okay, so what we can do next is to just substitute the reaction function into our inverse demand function here in order to get the leader's output. And the approach here is, again, a profit maximization problem over QL, and the profit of the leader is A minus QL minus N minus M times RF, so the reaction function, minus constant marginal cost times QL. So the only thing that might seem, probably when you first see it, everything looks confusing, but here it's pretty easy to understand. So what we have in this part here is the inverse demand, where we have already substituted for QL, and we have assumed that all other firms, except for the leader, which is N minus M, behave the same, and they produce the reaction, or the output that is determined by the reaction function of the follower, or of a given follower. So if we have our 9 firms example where 2 firms merge, then N minus M would be 8. So we have 8 followers and 1 leader. Sorry, we have 7 followers and 1 leader. So we had 9 firms pre-merger. We take 2 firms out, and from the 7 remaining firms, we have, from the 8 firms that we have in a post-merger situation, so there's 1 leader and 7 followers. And here we have the behavior of the leader and 7 times the behavior of the follower, right? And if we solve for that in equilibrium, so what we basically do is to just substitute RF as a function of QL here, then we have our objective that we can differentiate with respect to QL, and what we see is that the only unknown here is QL. So we can rearrange for QL, and what we see is that we arrive at this expression. And what this expression actually tells us is that this is exactly the monopoly output, right? So if we had 1 firm supplying a market characterized by this demand and this costs, then this would be the monopolist's output, right? Or the profit maximizing output. So what we see here is that the merged entity, if it can act as a Stackelberg leader, it will behave as a monopolist, or produce the output of a monopolist. And if we substitute this into our reaction function, then we get the output of the follower. We see that this is smaller, right? So we can immediately see that because the denominator is larger than the denominator here, and the denominator is the same, right? So if we now compute profits of the 2 types of firms, so leader and follower, and if we also look at the consumer surplus, then we get these expressions here. And now we can look whether the merger pays off, right? And what we have to look at is the leader's output and of 1 merged firm, and the pre-merger profits of M firm in the original situation. If you just rearrange that, you will see that this always pays off, right? Because the leader's output is so much higher than the pre-merger profits of one of the merged, or of M times the pre-merger profits, which is canonical. And it can happen that, what you can also see is that the merger also raises consumer surplus because prices will actually be lower, right? However, the Stackelberg followers are in a disadvantaged position, which means that the non-merged entities will lose profits. And that is kind of like a little bit counterintuitive, as if you go back to my 9 firm example, if 2 firms merge and they become the Stackelberg leader and all other firms are in a disadvantaged position, why shouldn't the other firms, or at least 2 of them, merge in order to themselves become a Stackelberg leader? That's a good question. This would be something that would be called merger waves. So 1 firm or 2 firms start to merge, and then another 2 firms, and so on and so forth, right? Okay, so this is basically another explanation why we could see or observe mergers in reality. And the last extension that we look at is differentiated goods, right? And that is pretty much very, I think, extremely realistic, because in most situations we don't have homogeneous goods, right? Well, that's difficult to say. I just please erase that or forget about this. But in many instances, it makes sense to look at differentiated goods rather than homogeneous goods, right? And for instance, if you look at the smartphone industry or chip industry or whatever, right? There's the profit or the products of a given firm are not the same as the products other firms produce, or there are inherent differences in the products that we look at, right? So I had this olive oil example, for instance. It depends on the consumer, of course. That's the nature of differentiated goods as well. So it doesn't always mean that every single consumer would consider these the examined products as completely different products at all, right? But some do, some do not, and that's what we capture in these functions, what we see here as well. But to our olive oil example, it would mean that there's, for instance, olive oil produced in Italy and olive oil produced in Greece, and some consumers might consider these two products as imperfect substitutes, which would mean that they are considered differentiated goods, but not all consumers and not for all purposes, right? It depends, right? But we cannot say per se that olive oil of Greece and produced in Italy is just the same, right? So that's probably not true. And that idea we're going to capture here and assume that we have three firms in the market and they compete à la patron and they produce differentiated goods. What this basically means is that each firm produces a variant of a good, and this variant are perceived from the consumer's perspective as the distinctive variant, right? So they're not the same. We also assume that the firms have identical marginal costs, so there's nothing, no asymmetry. The asymmetry here only comes from the consumers perceiving the products as imperfect substitutes. And we now formulate a demand function for a given variant I, as we see it here. So the demand is a function of each variant's price. So I, j, and k, with I, j, and k being either 1, 2, or 3, and not the same as the others, of course, as consistency. And what you see is that we have something like a intercept here. Then we have a slope parameter beta for the own price and a slope parameter gamma for the two other prices. We could differentiate this even more, where we say that each variant has a distinctive slope here, but here we don't do that. We just assume that from the viewpoint of I, the other products j and k have the same slope, right? And it's important to assume that this beta exceeds the gamma. So the slope of this function with respect to the own price is higher in absolute terms than the slope of the other prices. So that means that if the own price changes, that has a higher impact on demand than if the other prices change. And another thing to note here is that here we have a minus and here we have a plus. What does this mean? Well, we assume that the products that we're looking at here are imperfect substitutes. That means from the viewpoint of a given variant, if the price, or if from the viewpoint of variant I, if the price for product I increases, of course your demand will go down. That's characterized here, or that is that comes from the minus here. But we also assume that, or it's also plausible to assume that and also consistent to have a plus here, because if the price for product J or product K goes up, then more consumers would ceteris paribus purchase product I, because it is relatively cheaper than the other products, relatively. So just going back to the olive oil example, let us assume that we look at olive oil from Italy, Greece, and France, for instance. I would be Italy, J would be Greece, and K would be France, for instance. And we would here have, the demand for olive oil produced in Italy depends on the price of the Italian olive oil, of the Greek olive oil, and of the French olive oil, and the slope, of course, in the own price. So if olive oil from Italy becomes more expensive, then demand for Italian olive oil, ceteris paribus, goes down. But if French or Greek olive oil become more expensive, then the demand for Italian olive oil will go up, ceteris paribus. Okay, so that hopefully makes intuitive sense, and we're going to work with exactly this function. However, there's a lot more to this differentiated goods demand functions that we will not cover in this lecture here. So if you're interested in that, I would advise you to look at the industrial organization lecture that Georg gave, and it's also available on Economics to Go, and just go check that out, as there's much more to this than we can capture here. Okay, so we use this function in order to get some ideas on how a merger would look like. And in order to do that, we start with a pre-merger equilibrium, or with computing the pre-merger equilibrium. And what we basically do here is pretty straightforward. We again maximize profits, and the only obstacle that we face is to set up the profit function. And it looks pretty straightforward here, as we maximize over Pi the profit of firm I, which is a function of the own price and the other two variance prices. And what we do is to take our demand function, which we have just discussed, and substitute this demand function times Pi minus C, so the margin times the output, and we get our profit function. And what we do is to differentiate this profit function, set equal to 0, and rearrange, and then we get a reaction function. And this reaction function looks as we have it here. Pretty straightforward. We're going to interpret this not in too much detail, but we will compare it to the post-merger reaction functions in a minute. And what we notice, though, is that first, coming from the background of our second lecture, where we've been talking about Cournot and Bertrand competition, what we see here is that we have a reaction function that is everywhere continuously differentiable, which means that we have something else than we had in the second lecture, where we had this reaction function that had kinks in it, right? So it looks different than our standard Bertrand result. And that's pretty straightforward, as we will see here that we don't necessarily and usually get an equilibrium that means that prices are equal to marginal costs. That is something that we would expect for homogeneous products, but not for differentiated products, right? And what we also see is that we have strategic complements, which means that the reaction functions are upward sloping in the instruments of the other firms. So that basically means that if you differentiate this reaction function with respect to Pj or Pk, the resulting expression will be positive. All right, upward sloping reaction functions indicate strategic complements. And there's a lot to it, actually, right? So first thing is, again, and that's important to take into account, we don't observe price equal marginal cost. And that is, you can solve this one here for Pi, Pj, Pk, or you can simply assume symmetry so that you substitute Pj and Pk for Pi and just rearrange the resulting expression, and you get to an equilibrium price here, which is alpha plus beta C over 2 times beta minus gamma. and that expression is exceeding C, right? So pretty straightforward. Why is that economically? Mathematically it's pretty clear, but why is that economically? And the intuition is that, or why did we have the Bertrand paradox in the first place? The thing is that if one firm is cheaper than the other in a homogeneous goods Bertrand competition, then all the consumers will buy from the cheapest firm, and we will see that if there's no capacity constraints, all firms buying from one supplier. And since the firms anticipate that, they will just undercut each other until they get to a point where price equals marginal costs. Here, this is not the case, because if one firm is less expensive than another firm, not all consumers will buy from the least expensive firm. Why? Because depending on beta and gamma, not all consumers will prefer the given product, because there's always a part in the market that will still buy something else, right? So coming back to our olive oil example, what we see is that if Italian olive oil is more expensive than Greek olive oil and French olive oil, not everybody will buy the Greek or the French olive oil, but there will always be people who prefer the Italian olive oil over the other olive oil variants, and they have basically a premium for this variant. And since, at least if the variant isn't too expensive, they will still buy the Italian olive oil. If you want to understand that in more detail, you should really check out the I/O lecture, as there we are talking about the Hotelling model, where this is explained in much more detail, and it's kind of related to what we have here. Okay, so based on this starting point, we have a merger between two firms, right? So we assume that firms I and J merge and they will become the merged entity I and J, right? And after the merger, each variant I and J is still produced. So assume that all French olive oil producers, or assume that there is only one. So the French olive oil producer merges with the Italian one, but this Italian-French collaboration will still produce Italian and French olive oil, right? And what they do is to maximize their joint profits. So no longer individual firms' profits, but joint profits. And this joint profit maximization problem looks as we have written it down here. And it looks long, but it's really just it's pretty simple. So what we do is to maximize over Pi and Pj. So we have two instruments, the joint firm's profits, which is a function of Pi, Pj, and Pk as before, but it's now just the sum of firm I's profit and firm J's profit. So the same as before, only for firm I and firm J. And from that, we can easily get to the reaction function of firm I by differentiating this resulting function with respect to, or this function with respect to Pi. And what we see is that the reaction function looks pretty similar, except for one term, and this is here in green, and this is that we add something to this reaction function. That means that we shift outwards the reaction function of firm I. That means that the intersection point will lie to the right, which means that prices will increase, right? And we have that not only for firm I, but also for firm J, because it basically looks the same, because firm J also internalizes its pricing decision on, or the effect of its pricing decision on firm I. Okay, so what happens here economically? So we already see that from a purely mathematical standpoint, the prices will be higher post-merger than they are pre-merger. And what happens economically is that firm I internalizes a positive externality on firm J. Now that immediately follows from prices being strategic complements here. Strategic complements means that a higher price of firm I will benefit firm J, and that's the externality. And here, since we maximize the joint profits of the two firms, we internalize this positive externality. And what this means in business terms is that we avoid cannibalization of firm I and firm J, right? And we have already talked about this effect in the context of upward pricing pressure in chapter F, right? So we just avoid that the firms cannibalize each other, which means that we have higher prices. Okay, now what happens to firm K, so the firm that is not involved in the merger? And for firm K, the profit maximization problem looks the same as we had analyzed it for firm I on slide 17. So the reaction function basically looks the same as in the situation where no merger is concerned. And the prices post-merger can now be computed as if we use the reaction function of firm I and firm J, which look the same, so their prices will be the same in equilibrium as well, and firm K, which has a different reaction function, right? So if we are in this plane approach, we have two similar-looking planes that shift outwards, and one plane that is basically the same. And that means that their intersection point will basically be higher. So in the end, firm I and firm J will increase their prices, and firm K will also increase its price, right? And if we compare the numbers here, you will see that the price increase of firms I and J is higher than the price increase for firm K. Something that we will not check here in detail, but you can do easily if you just plot the two functions, for instance. And what happens here economically is that we have an umbrella effect and a business stealing effect. These two effects are very important in the discourse on, or especially umbrella effects, in the competition policy debate and analysis. Umbrella effect is here the situation where the merger between firm I and J creates a positive externality to firm K, such that firm K can increase its price. So there's basically a pricing umbrella that the two firms I and J, they just generate for firm K, right? And that doesn't necessarily happen only from mergers, that also can happen from cartels, for instance, right? So if there's if two firms collude, prices increase, then even firms that are not involved in the cartel will have the ability to raise their prices. And that's the same that we have here. The other thing is that we have a business stealing effect going on here. That means that firm I and J will increase their prices, and firm K thinks, okay, I can increase my price as well. However, I'm smart. I will still try to steal some customers away from firm I and J. So what happens is that firm K will increase its price, but not so strong as firm I and J's price increase, because firm K will use the price umbrella to increase the price, but not too strong because I want to take away some customers from firms I and J. And the result of that, in the end, is that prices increase. Pretty clear, we see that here in the slide. Profits increase, as there is no detrimental effects. It's pretty clear that this has to happen here. And consumer surplus decreases. Prices increase. Now, there's not much that can happen from the viewpoint of the consumers that they could benefit from. So these types of mergers would, from the perspective that we have here, also be blocked from a pure consumer welfare standpoint. Here we have just plotted these functions. What you see here is on the left, the equilibrium prices. Orange is the price of firm K, so the firm that is not involved in the merger, and firms I and J, which is basically the same. And what we see is that the non-merging party will price below the merging parties. And here you see the profits of the pre-merger of the firms I and J, the profits of firm I and J, so the merged entity, and of course of the of the non-merging party. And you see that the non-merging party benefits from the merger. Okay, so lastly, we talk about some specificities and some competition policy aspects. And the crucial thing here is that all that we've talked about, a competition authority should or must anticipate, right, in order to make a decision. And in order to assess that, to assess the effects of a merger, you have to have some understanding of the market, and you have to make some prediction. And that can be pretty tough depending on the market we're looking at. The question is, what can we do and how can we do that? And this merger simulation, so understanding what happens when two firms merge or more firms merge, there can be structural analysis going on here. And these structural analyses, they require some assumptions, and their application, of course, also depends on the characteristics of the market and on the available data, of course. So first of all, you have to have a certain understanding of how demand looks like, of how cost looks like, and how the firms compete, and also about potential competition and so on, because I mean in the European Commission's assessment that will be later, but still you have to have some idea on that. And how you actually make the merger simulation work then is then based on these things, and of course also based on the available data. So what you want to have is a certain idea on demand, and if you want to identify demand, it's pretty tough because all you see is the equilibrium outcomes of a market. So you cannot distinguish if there's a price change, whether we have a change in demand or in supplies. We have an identification issue here, so that's from an econometric standpoint pretty tough to isolate, and therefore we have some techniques here. We can have logit, we can use logit estimation, nested logit estimation. We can use varied evidence and Pecos, which is a little bit more sophisticated method to back out demand. We can have almost ideal demand system, which is called AIDS. Pretty, yeah, I mean the name is as it is. And this method all have their pros and cons, and all require different types of data. So depending on the market at hand, we can apply one or the other, whereas varied evidence and Pecos would be the most sophisticated of these methods. What we can also do is basically sit down, get some understanding of the industry and how it works, write a theory model, and then calibrate the parameters that we need. That would basically mean, in the example that we have to find numbers for alpha, beta, gamma, and C in order to solve the system that we have here. That can also be pretty tough, but it doesn't require all this econometric stuff. Whereas the econometric stuff is there for a reason, so it's probably smart to at least look whether this works. And of course, we have to use a case-by-case comparison here, so it is probably impossible to say that every merger has to be assessed, or there always has to be a merger simulation using BLP. That wouldn't work, right? And it's also probably not smart to only use one of these techniques. It's always a good idea to have some sort of understanding of how the market works, so basically a descriptive idea, and you also want to have some theoretical intuition on the market forces that play a role, and you want to have econometrics running in the background or at the front end, depending on what you can do in order to get a clear, broader picture of how the merger will work. And ideally, everything ties in very well and is consistent, and then you can make a solid prediction. What you also do is you take the pre-merger conditions as a starting point, which is pretty clear, and technically you want to get an understanding of the counterfactual. So what happened if there would not be a merger? That's a crucial point. So it's always a question, what would happen if the firms didn't merge, right? Would there probably be product or process innovation that wouldn't occur, that would only occur by the merger? Would there be efficiency effects, as we've talked about? And can this efficiency effect outweigh potential price increases? Could there be foreclosure or market entry that is deterred over the course of the merger? Is there probably one of the two merging parties going to fail in the future? In which case, the merger is probably the only way to maintain some sort of competition. That's all questions that you should think about in real-life applications, whereas not all of these will always be relevant, of course. Okay, so that would be it for horizontal mergers. In the next lecture, we're going to talk about the vertical merger component, and I hope that you will join us, and I'm very glad for your attention. So please, before we finish the video, please make sure to like this video and to subscribe to our channel. Okay, then see you next time.